Hello everyone. Today we are going to analyze this frame using moment distribution method. Before analyzing, let us see the frame one time. In this frame, we have the columns AB and CD. Also, we have the beam BC. In the column AB, there is no load. In the column CD, we have uniformly distributed load 6 kN per meter. It is acting towards the left side. In the beam BC, we have a point load 16 kN. The moment of inertia for the columns is 2I and for the beam it is I. Height of the columns is 4 meter and the length of the beam is 5 meter. This is a Sway type frame because the loading in the frame is not symmetrical. Because of this uniformly distributed load, there will be sway. This load is acting towards the left side, so the sway also will be acting towards the left side. Since it is a sway type frame, we have to do the analysis two times. First the non-sway analysis, then the sway analysis. Now let us start the non-sway analysis. We know that the sway force is acting towards the left side. To stop the frame from swaying, let us assume that there is a roller support in the point B towards the right side. Now let us find the fixed end moments. In the column AB, there is no load, so the fixed end moments M of AB and M of BA will be 0. In the beam BC, we have a point load 16 kN. It is acting in the center. The formulas to find the fixed end moments are minus WL upon 8 and positive WL upon 8. Here W is 16 and L is 5. For M of BC, we will get minus 10 and for M of CB, we will get positive 10. Now let us take the column CD. In the column CD, we have uniformly distributed load 6 kN per meter. It is acting for the full span. The formulas to find the fixed end moments are minus WL square upon 12 and positive WL square upon 12. Here W is 6 and L is 4. Finally, for M of CD, we will get minus 8 and for M of DC, we will get 8. In the moment distribution method, we have to find the distribution factor. To find the distribution factor, we have to calculate the stiffness. Let us see the formulas to find the stiffness. If the fare-end is fixed, the formula is 4EI upon L. If the fare-end is hinged or with roller support, the formula is 3EI upon L. If the fare-end is continuous, the formula is 4EI upon L. In this frame, in the ends A and D, there are fixed supports. The joint B and the joint C are considered to be continuous. So for all of the members, we have to use the same formula 4EI upon L. First, let us find the stiffness for BA. Length of BA is 4. Let us apply that. The moment of inertia for BA is 2I. So instead of I, we have to apply 2I. Finally, we are getting the stiffness as 2EI. Let us find the stiffness for BC. Length of BC is 5. Let us apply that. After the calculation, we are getting 0.8 EI. Let us find the stiffness for CB. Length of CB is 5. Let us apply that. Finally, we are getting 0.8 EI. Let us find the stiffness of CD. Length of CD is 4. Let us apply that. The moment of inertia for CD is 2I. So instead of I, we have to apply 2I. After the calculation, we are getting 2EI. Now let us find sigma K. In the joint B, we have to add these two values. After adding, we are getting 2.8 EI. In the joint C, we have to add these two values. Here also, we are getting 2.8 EI. Now, let us find the distribution factors. The formula is K upon sigma K. We have calculated the K values and sigma K. Using the formula, we can find the distribution factors. Now let us start making the moment distribution table. In the table, first let us enter all of the members, then let us enter the distribution factors, then let us enter the fixed end moments. Now let us make the first distribution in the joint B. For that, we have to add these two fixed end moments and then multiply with the distribution factors. When we do that, we are getting negative values, so we have to apply inside the table as positive. Now let us make the first distribution in the joint C. For that, we have to add these two fixed end moments and then multiply with the distribution factors. When we do that, we are getting positive values, so we have to enter them as negative. Now let us do the carryover. For that, we have to divide these values by 2. When we divide, we are getting these. Now let us do the second distribution in the joint B. For that, we have to multiply this value with the distribution factors. When we do that, we are getting negative values, so we have to enter them as positive. Now let us do the second distribution in the joint C. For that, we have to multiply this value with the distribution factors. When we do that, we are getting positive values, so we have to enter them as negative. Now let us do the carryover. For that, we have to divide these values by 2 and enter the answers. Now let us do the third distribution in the joint B. For that, we have to multiply this value with the distribution factors. When we do that, we are getting negative values, so we have to enter them as positive. Now let us do the third distribution in the joint C. For that, we have to multiply this value with the distribution factors. When we do that, we are getting positive values, so we have to enter them as negative. Then let us do the carryover. For that, we have to divide these values by 2 and enter the answers. In the similar way, we can do more distributions and carryovers until we are getting very smaller values. I have done up to the fourth distribution. I have stopped in the fourth distribution because in the fourth distribution I am getting very smaller values. In the last distribution, we have to give the carryover to the fixed ends. Now let us add all of the values and find the moments. After adding, we are getting the moments. Now we are going to find the horizontal reaction in the point A. For that, we have to take the moments in AB and BA. For both of the moments, we have got positive values. That means both of them are acting in the clockwise direction. Let us assume that the horizontal reaction HA is acting towards the right side. To find HA, let us take moment about B. In this case, we are moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. HA is acting in the anti-clockwise direction, so that will be negative and the distance is 4. So minus 4 HA. Both of the movements are acting in the clockwise direction, so both of them are positive. After the calculation for HA, we have got a positive value. That means our assumption is correct. HA is acting towards the right side. Now we are going to find the horizontal reaction in the point D. For that, we have to use the moments in CD and DC. For the moment in CD, we have got a negative value. That means it is acting in the anti-clockwise direction. And for DC, we have got a positive value. That means it is acting in the clockwise direction. Let us take the column CD and find the horizontal reaction HD. Let us take moment about C. In this case, we are moving towards the left hand side. Clockwise will be negative and anti-clockwise will be positive. HD is acting in the anti-clockwise direction, so that will be positive and the distance is 4. This movement is acting in the clockwise direction, so that will be negative and this movement is acting in the anti-clockwise direction, so that will be positive. The uniformly distributed load 6 is acting in the clockwise direction, so that is also negative. When the UDL comes, we have to multiply with the distance and distance by 2. After the calculation for HD, we have got a positive value. That means our assumption is correct. HD is acting towards the right side. In the frame, in the joint B, we have given a roller support. Now let us find the force P in the roller support. To find it, let us apply the rule sigma H is equal to 0. P and these two reactions are acting towards the right side, so all three of them are positive. The UDL is acting towards the left side, so it will be negative. The distance of UDL is 4. Finally, for P, we will get 10.125 kilonewton. We have found the value of P preventing the sway, which is 10.125 kilonewton. It is acting towards the right side, so the sway force should be acting towards the left side. The value of P and the sway force should be same, but the directions only will be different. We have finished the non-sway analysis. Now we are going to do the sway analysis. Let us start the sway analysis. In sway analysis, we have to remove all of the loads in the frame. We know that the sway occurs towards the left side. So let the frame sway by delta towards the left side. Now we have to find the ratio of the fixed end moments M of BA and M of CD. The formula to find the moment developed due to sway is 6EI delta upon L square. Since the sway occurs towards the left side, the sway moments will be positive. Let us apply the values inside the formula. The moment of inertia in AB and CD is 2I. So instead of I, we have to apply 2I. Length of AB and CD is 4. Let us apply that. Finally, we are getting 1 upon 1. Let us keep the fixed end moments M of BA and M of AB as 1. And let us keep the fixed end moments M of CD and M of DC as 1. The beam BC is not affected by sway, so the fixed end moments in the beam are 0. Now let us start making the moment distribution table. In the table, first let us enter all of the members, then the distribution factors, then the fixed end moments. Now let us do the first distribution in the joint B. For that we have to add these two fixed end moments and then multiply with the distribution factors. When we do that, we are getting positive values, so we have to enter them as negative. Now let us do the distribution in the joint C. For that we have to add these two values and then multiply with the distribution factors. When we do that, we are getting positive values, so we have to enter them as negative. Now let us do the carryover. For that we have to divide these values by 2. When we do that, we are getting these values. Now let us do the second distribution in the joint B. For that we have to multiply this value with the distribution factors. When we do that, we are getting negative values, so we have to enter them as positive. Now let us do the second distribution in the joint C. For that we have to multiply this value with the distribution factors. When we do that, we are getting negative values, so we have to enter them as positive. Now let us do the carryover. For that we have to divide these values by 2 and enter the answers. In the similar way, we can do more distributions and carryovers until we are getting very smaller values. I have done up to the third distribution because in the third distribution I am getting very smaller values. Now let us add the values and get the moments. After adding, we are getting the moments. Now let us take the moments in AB and BA and find the horizontal reaction in the point A. For both of the moments, we have got positive values. That means both of them are acting in the clockwise direction. By taking moment about B, we can find HA. For HA, we have got a positive value. That means HA is acting towards the right side. Now let us take the movements in CD and DC and find the horizontal reaction in the point D. For the movements in CD and DC, we have got positive values. That means they are acting in the clockwise direction. By taking movement about C, we can find HD. For HD, we have got a positive value. That means our assumption is correct. We know that the Sway force S dash is acting towards the left side. By applying this rule, we can find S dash. Now let us find the correction factor K. The formula is S upon S dash. We have calculated S and S dash. Let us apply them. Finally, for the correction factor K, we are getting this. Now let us make a table. In the table, first let us enter the movement names. Then let us enter the sway movements. Then we have to multiply the sway movements with the correction factor. When we do that, we will get these. Then let us enter the non-sway movements. When we add these two values, we will get the final movements. Here you can see the bending moment diagram. Now we are going to end this session. Thank you for watching this video.